So we have logged into Datastage Designer and we are going to create or see the parameter set. We have seen the parameter set yesterday. We are going to see how the parallel job works now. I'm going to create a parallel job here. And the first thing in the parallel job is the properties. If I go to job properties, if I go to parameter section, I can see there are a few options here created, like add environment variables, parameter sets, view parameter sets, and create parameter set, which are disabled. So for these to get enabled, I need to create some values here. Like if I create a test parameter here, a value name, the create parameter set get enabled, meaning I can create a couple of parameters, say test and test1, and I can club them, select them, and say create parameter set. So with these two parameter sets, my parameter I will be able to create a new parameter set. So if I have mentioned 2 or 3 values in the parameter section and I want to club them as a parameter set stored in my data in the project, I can do that by selecting them all and selecting the option of create parameter set. And then these two options will come here, giving them a name, say test param, and clicking on OK. So then it's going to ask me where it should be stored. So I will come here in the parameter set section and save it. This is how it will get stored. So now this parameter set is getting stored in the parameter set folder. In order to check that, I can go back to the parameter set section and see, yes, the test param has been created. So this is one way of creating test parameter. Another is I will go to file, click on new, select parameter set, which is also available in the other section. I can select the parameter set, provide a name, test param1, parameters in the same way we have created, and we can click on OK. It will get created in the same whichever folder we say. Normally we'll provide the information in the parameter set folder itself, so that will go to the parameter set folder. So that is how these the parameter sets get created. We can add environment variables to the parameter set as well. Like in this parameter set, I can add certain environment variables. Say I am adding apt configuration file. I'm adding another one, which is apt disable combination. I'm adding the third one, which is say apt dump score. So I've created a parameter set with these 3 variables. Let me change the name as, now these are nothing but this parameter set has environment variables only. So let me mention the parameter set name as env var, environment variable, right? And I can click OK. So it will again ask me where to store. I will say save it in parameter set section, and this parameter set will get stored and created. So we can see that we have environment variable parameter set, we have test parameter set, we have a parameter set for Oracle connection. Now what does it mean? What does this parameter set mean? If I double click on this, I can see the parameters in this section is server, username, and password. We can also see there are certain values. The values are for Scott, system, and training. The password of training has changed recently, so let me update that, and I'll click OK. So now I have 3 values in here. We'll see how we can use these values in my job. So when we'll be designing using the connections, Oracle connections and all, we'll see how we can do that. As of now, these 3 values are there, which can be used, and the parameters are server, username and password, and the name is Oracle underscore connection. You can provide a short description and a long description just to ensure or make others understand what these parameters actually are all about. So after making the changes, I'm storing this variable. So now we have the parameter sets created. We want to use these parameter sets, or we want to create certain parameters and use it in our job for the job to execute. So for that, let me go ahead and add certain parameters here. Rather than calling them as test and test1, let me call them as source path and say target path. Okay, and Yeah. So now I'm just using these two and I'm creating another parameter set. The reason I'm showing this again and again is you will get used to and you will get a clarification or idea like, okay, how these are supposed to be created. So I'm saying the parameter set name is path. The parameters are these. The default values. For default values, let us create a folder where we can create all these default values. So how about we use the temporary folder for our default for our all the files that we create. So we will mention the default folder here, right? And let's click OK. We can even add parameters environment variable here as well. As we can see, the option is enabled. So, but I want to create separate parameter set for separate entity, meaning it will give me an idea what these parameter sets are all about. Like one was created for Oracle connection, another one is created for environment variable, the third one I'm creating for the path. So it makes me clear like, okay, what these parameter sets are all about. And again, I will provide the parameter set path and I will save it. Okay. Uh, Let me refresh my repository and see if path. Okay, so path is not coming. Yeah, it has come. So we can see that the path parameter set has come here. Now I just want to use the parameter sets that we have created, or for the sake of this job design, this is the first job that we will be designing in Datastage. So for the sake of this job design, and the job that I'm using, the job that I'm going to create is something related to using a row generator. So there is a stage called as row generator which will generate dummy records. So I will be using that stage to to start with the job designing part. So for that purpose, I don't need actually any parameters created. So I'm not going to create any parameters as of now. We'll see if required in the job. We can go ahead and modify the parameters or create certain parameters. So let me first save this job. The job name is g underscore origin underscore one, and I'm saving it. So the job is created. Let's start designing it. So for that, I need to go to view and click on palette. Once you click on palette, I can see these are the different options: general, database, development and debug, file. So these are the different options where the jobs are available. So I will go to development slash debug and I will click on row generator and bring it here. So we can click on row generator or any of the stages that is available, like whatever we see, say a peak, right, and bring it here. Now we need to connect. So I have created a row generator and I have dropped in a peak stage. We need to connect these two. That has to be connected through the link. So right click on the stage, drag your mouse toward outside. Right click on the source. After putting the arrow on the stage, right click and drag it out. So we will get a link and we can connect the two stages. So this is how we can create or we can connect the two stages. First of all, what row generator stage is used for? Well, row generator stage is used precisely for creating dummy records, dummy entries altogether. It uses certain algorithms and certain informations, and based on that, it will create dummy entries uh, into or dummy data, I should say. Now, these dummy data can be used for testing purposes. So that is the reason we provide information about row generator. We learn about row generator at the first stage, being the easiest one. We get a glimpse and feel of data stage designer, how it looks like, and how we can go ahead with that. So the row generator being the first stage, let me double click on it and you see the first option that it is saying is the number of records equal to 10, meaning this is the number of dummy records it is going to create. And then I will go to the column tab and I need to create column here because it is going to create dummy entries, dummy records, and row generator is a source entry, source record, source stage, meaning it will be creating source data. I cannot put it anywhere else. Like we have say a database connection, so I can put a database connection at the source, at the lookup, or at the end. right? In the same way, as a file stage or a dataset stages can be placed anywhere among the three options like start or the end. But row generator cannot be placed at the end. It has to be placed at the start. We can only get data out of it. We cannot pass data through it. So it has to be the first stage always. Or I should say the end stages. Somewhere the end stages, not the last stage. Like if you want to do a lookup, so then it can be a lookup stage. So it can give you the dummy records for lookup purpose, but it cannot be the target stage. So let me provide certain column names here. Say okay. So I'm just providing certain column names here, and I'm making the changes in the data type. So I provided account number, account name, amount, and address. Four values, 4 columns. Account number, normally an account number is a numeric value, so let me mention it as integer. Account name normally is varchar, so let me mention it as varchar. Amount is again an integer, and address is again a varchar. So there are four columns, and 2 of them are integer, 2 of them are varchar. Let me also provide the length of them. So normally an account number will be say 10 or 12 characters, not more than 20 characters. So let me provide it as 20 characters. Account name, let me say 50. Amount, say 10, and address again 50. So with these, I have provided the basic information about how the column and what are the column values it will have. Now it's going to generate certain dummy data. It's going to generate certain dummy data. So for that, it has an algorithm. It has to execute those algorithm. We need to provide information about those algorithm. For that, we need to go to these options at the left hand side, 1, 2, 3, and 4. These options, we have to select one of them, and we have to go to the generator option, which is in the middle in the properties, and click on type. So the options and type will come as cycle or random. So it will say cycle or random. So it will either generate a random number or it will generate a cycle of n numbers. So how about here I give a okay, what will happen if I give cycle? Let's see. So if I say cycle, then, or let me say random here. We'll talk about cycle in the second scenario. So if let me give random here. I'm saying okay, it will be random, and limit is so 9 letters of 9. Okay, and I click apply, and so with this it will create a random number. Okay, and with the maximum limit of 999, so it's going to create a random number with the maximum value of 999. So it will start from somewhere, and it will create this maximum value. The next is, if now for this the account number, the information we have already provided, so we are good with that. Then now we'll click on the next. We go to the algorithm for account name. Again, we have to go to the bottom, algorithm, cycle, and so in the previous section, right? In the previous section, or okay, let me apply and say close. Let me go back to account number. Numeric. It's nothing but the same thing, numeric and integer, just that integer can be negative as well, but numeric will be positive only in this case. So if it is only positive, so we can give some sort, or it in numeric case we can give any values. We can provide our sort of start value and the end value. That is the difference. So that is why we are going with numeric case, because I can say okay, the initial value is say 1111111, and I can give increment by say 121, certain random numbers I'm just talking about, and the limit is so. Now with this it becomes clear that okay, this algorithm is going to create me dummy records, but it is going to start with the initial value of this. increment by 121. So every new value will be created with an addition of 121, and a limit value is 9999. So it becomes very clear that okay, the cycle that I'm generating is something like this. And let me click on apply. So this is about the type of numeric. Now what I'm just trying to show is the algorithm for numeric, integer, decimal all remains the same. Next is the algorithm for varchar. So varchar has two algorithms, cycle and random, or I should say alphabet. Alphabet is nothing but a random algorithm. So we'll look into that alphabet part in the address section. So in algorithm for cycle, I am saying we need to provide certain values. So what are the values I will say? Let me say I'm just trying to give certain name. And we can give any dummy values as well. Not necessarily a name, but because it's a cycle, so I can give any number, any values, and any number of values. Now, point to note is the values I just provided six numbers, say 5 or 6 values. Now that means after these 5 or 6 values are done, it will start repeating. So it will cycle it out. So that is the reason I just give. I mean, providing these values in this section may not be a good practice, like using an algorithm for cycle, because with the moment I use an algorithm for cycle and it is starting, it's keep on repeating. However, my account numbers keep on changing with a number of 121. So that means there'll be a mismatch. The account names will get on start duplicating, whereas the account numbers are unique, which is not an ideal situation. So the best would be if we use a different algorithm rather than cycle. In certain situations, we use cycle algorithm. Suppose the account type. So we can I can show you that part, the algorithm as well. I mean, in one of the example, I will put it. As of now, let me use alphabet, which will make sense, like what it is trying to go about. So I use alphabet, then I am selecting string, and I can give all the digits or all the numbers, which whatever I provide. Based on that, it will take one or n number of values. The n is provided by the length. So from 1 to 50, it will take any number once or 50 times. So all these different algorithms, the permutation combination will get implemented, and a unique number will be, or a unique string will be created from this number that we have shared. This is about the varchar section. Let's go to the next, where it is amount. Again, amount, I'm going to select type, and I want it to start with a random number. Limit with say 200. So it will start from maybe 1 and it will go to 200, and that random number it will generate. So let me click on apply. Then the next is again address, or let me change the name here as account type, because in address also we need to have a different address. So that means again we have to go back and see this see the random generation of the varchar type, which we are not looking forward right now. So we have, because we have already used that in account name section. We want to use the the second algorithm that is available, which is nothing but cycle. So that is why we have used this account type, and I can provide values like saving, credit card, demat, certain 3 accounts. So that even if it cycles out, it's not going to make any difference. It will work perfectly fine, because in that case I'll be able to test it out against the different cycles that I have, against the different account types that we have. So having said this, let me apply and close it. Now I have all these 4 numbers created, the algorithms for all of these 4 created, and I can simply go ahead and execute this stage, and it will create me records. So all the property setup for row generator has been done. This is what it requires. It requires me to provide the 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 column names, the data type, the length, and the algorithm that I'm supposed to use. And with this, the different information is done for the row generator. I can click on OK. I can even go right click here and rename the row generator name as row gen underscore 1. Right. Similarly, I can right click on the link and I can rename the link lnk underscore peak, link underscore peak. So this suggests that this link is going to the peak stage. Then I can right click on the peak and I can say peak underscore dummy data, because it's looking at the dummy data. So the dummy data that I'm creating from row journal is going to the peak stage. Peak stage is simply used to give me information about what records are coming. It is also used for a testing, for development and testing purposes. As the name suggests, it's there from development / debug stage section. So it is also used for development and testing purposes. More information about the peak stage we will be seeing in a while. As of now, let's go and see how row generator stage works. So with this, let me store and compile my job. So I will click, either we can click Control S, which will save this job because already the name, we have already put a name to this job, and then I can compile. So this option over here is going to compile my job. So this option here, this one is going to compile my job. Then the next one is run. So I can click on that and execute my job. Now, so I can see that the 10 records has been processed. Why 10 records? Because in the row generator section, I have provided information about number of records equal to 10. So it is only going to create me 10 records. Now the second thing is, okay, the data has been created, but what are those records? So I can look at the content of the peak stage. It's not going to create a sequential file, or it's not going to create any file, no temporary file, no sequential file, nothing. The content of the peak stage is only visible in the Datastage data director log, only in this job log. So that is a cleaner approach of doing testing. That's a cleaner approach of doing testing, because you're not ending up creating any file, right? So in any development or production server, if we are supposed to do any testing, if any issues has come up and I want to look at that kind of data and other stuffs, so in that case, if I create for each and every testing, if I create X number of testing files, that doesn't make sense. However, if I create a peak stage and look into the data, I will get an idea about what is the data or what content it has. And on top of this, I will also be going for a cleaner approach, not creating any temporary files or any testing files in my folders. So that is the reason we use peak stage whenever we want to do our testing. However, if the files are already getting created as part of the job, we can use the files, we can check the content in the file itself. But if at all the job is designed so that we have a source from a database and target as a database, no intermediary files, no intermediary stages which contains the data, so then in that case the advisable section is we use a peak stage, so that we can peek into the data without affecting or creating new files. So if I want to look at the log, so there are two ways. I can go open a Datastage director stage altogether on the in parallel, or I can just simply press Ctrl L. It will show me the log at the bottom. So I can see that this information peak underscore dummy data 0, peak underscore dummy data 1. Two options are there. Now dummy data 0 is for dummy data for this dummy data with 0 partitioning. I mean 0th partitioning, and dummy data 1 is with first partitioning. So there are two partitioning. How we will know it's two partitioning? The information before that is saying that apt configuration file information is this. If I double click on this, I will get an information like the node 1 is this and the node 2 is this. So that means this job is executing only on 2 node configuration. There is no more nodes for the execution purpose. So with that I got to this information that okay, yes, the job is executing in only 2 servers. Again, the information like PC, project name, job name, username. So all these informations are available over here. Now let me look at what is the content of the peak. So now peak says that they are peak dummy, dummy. So they are giving me some records and it's generating certain numbers. You can see the numbers are it's starting from from the number that we gave 1111111, and it added zeros at the start. Why zeros? Because we gave the total number of characters to be 20. So it added zeros at the start so that it becomes total 20 characters. And similarly, account names are coming as AAA, CCCC, EEE. So all G's, all I's. What does that mean? Is it's generating these account names using the random number with a set of values like A, B, C, D, and all that. So it's just generating the numbers. The increase in the number of records that we generate, these values will keep repeating. So we may see that A is coming multiple times with uh, with the number of occurrences of A getting changed. Like it may have one character of A, it may have 10 characters of A. So the number of occurrences of A will get changed. It completely depends on the number of records that we are trying to process. At present, we were processing only 10 records, so just a limited number of records are coming. So the algorithm has to generate only a selected number of records. So the selected number of values is good enough for this account name section. Similarly, account type, you can see saving, demat, credit card. How about I'm just putting them in the notepad so that we can clearly see. So we can see that the account type is saving, account type is demat, then account type is credit card, again saving, demat, and so on. So the cycle repeats. Then account amount is 53, 27, 31, 30, 167. So again the amounts are also getting repeated. Getting randomly generated using the values. So this is how we create dummy data. Now the question can be like, okay, we wanted to generate 10 records, but we are only getting 5 records. So where are the remaining 5 records? Well, this is the partition 0 that we are looking at. Let's click next and get the remaining set of partition 1 data. Now this is the total complete 10 records. We see the name remains the same, peak underscore dummy data comma 0 and peak underscore dummy data comma 1. So there is a difference. Comma 1 meaning that those records are going to partition 1, and comma 0 meaning that those records are going to partition 0. So there are two partitions, 0 and 1. Okay. Now precisely what is happening is what kind of partitioning it might be executing in the background. It might be executing uh, uh, it might be so that the first record is going to the first partition, second record is going to second partition. If you look at that pattern, right? So first record is going to first partition, second record is going to second partition, third is going to third partition. That is what is happening, right? So if you see, let me first prove that content, then we'll look into the partitioning that we have. So if I just, based on this understanding, if I just cut them and dump the records properly. Now let's have a look. How we will find out if the first record is going to first partition and second is going to second partition? Okay, here is it. What if you remember, we said that the account numbers will be increasing by 121. So if we add 121 to 111, it becomes 232. If we add again 121 to 232, it will become 353. If we add 121 to 353, it will become 474. Then 595. Then if I want, I can bring the 716 record over here in the middle, then 958 records over here before this, and so this pattern goes on. That is how this pattern keeps going. So it's nothing but each record is going one by one. So each record is going one by one to different partitions that we have, and this kind of algorithm is nothing but round robin algorithm. If you remember, in round robin we had this kind of algorithm where first record will go to first partition, second record will go to second partition. Now how Datastage automatically selected it to be a round robin algorithm? Because if you go to the row generator stage, right? So if you go in this stage, we have not provided any specific algorithm. There is no option of providing any specific algorithm. We have selected all the different places, all the different choices, all the different values. There's no option of providing all the different any of the algorithm, any of the partitioning algorithm. The reason I went through this is to just to showcase that okay, here we do not have any choice, any option, meaning by default it is going to implement an auto partitioning method, and with that a round robin algorithm. Because as I told you, row generator stage is going to be the first stage. Always it's going to be the first stage. So that is the reason it's going to create a round robin partitioning algorithm, and with round robin it's going to it's an auto with a round robin, and there is no option. We'll see in the stages like join and other stages that join, lookup, merge, or any of the stages that yes, there is an option of round of providing the partitioning type. So we'll look in that in those stages. So this is about the row generator stage, but then now it was generating only 10 records. If I want to increase the number of records, how can I do? I will go to the properties section, increase the number of records to say 100 and click on OK. Now the drawback of this approach is I have to recompile my job because I made some changes. That means I have to save and recompile my job and execute it. So well, although this will work fine, it's going to generate 100 records, but there was an overhead that the number of records that is supposed to be created, I had to modify that in my job and then compile and execute it. That is the only situation where I will be able to see that the records get created. So we see that the records are getting created. Okay, so this is fine, but the issue remains the same, that it has to be modified at the runtime, which I'm not looking forward for. So how do I fix that? In order to fix it, let me go to the job properties tab again, and let me provide a parameter called as counter. Okay, so and let me say the default value as say 50. Click on OK and use this parameter in my job rather than using the a hard-coded number. If I use this parameter in my job, so I will just clear those number of records, going to on the rightmost section here, which is a small arrow, and click on insert job parameter, click on counter, and the variable comes here. That job parameter, that variable comes here, and I can click on OK. Now if I compile my job and execute it, so it's currently executing for counter equal to 50. The number of records will be 50. So it's going to generate 50 records. So if you see, it has generated. Okay. So now we are not able to see all the records coming up because of the peak stopping. Peak stage has a drawback that it is stopping the number of records that we are just trying to load. Let me change that and use counter here as well, so that we do not stop anything. We'll look at the peak stage properties in later on, but I am just ensuring that we do not stop any number of records. So whatever we generate, all those records should be logged. Now for 50 again, I'm going to execute my job, and so we see that the 50 records have been generated. So all the 50 records are coming up here, right? We can look at the same at the data as well. So because all the records are getting logged, now we have made the changes in the peak stage, so all the records are getting logged. How about I want to execute for say 100 records? Again, I do not have to compile. With this modification, I do not have to compile. I can just mention the changes here, and while execution, so the changes is being accepted at the runtime, and I can click on run. So at the runtime, the values are getting modified and the number of records being processed is getting changed. We can see that the 100 records have been processed. How about without recompiling it, without making any changes, I want to execute it for say 200 records. Will it work? So we can see that with this approach, the job design is cleaner, and we can modify the values at the runtime only just by changing the parameter value, the value of the parameter that it holds. So that is the beauty of using the parameters in Datastage jobs. The values can be changed at the runtime, meaning we do not have to worry about. And that is why whenever we try to create our data stage jobs, we tend to create in such a way that we can put in these variables there, these parameters, so it becomes easy for us to design our job and modify it at the runtime. So that is about the row generator stage. Now let's look what is peak stage and how it works. So as we have already discussed about the peak stage, that the peak stage is used to just peek into the data. Like we are seeing that we are only peeking into the data. So we are just getting a glimpse of the data. We are not creating any files. We are not creating any junk files or anything. We are just, all these records are coming to the peak stage in the datastage.log. However, peak stage has a property where though we have modified the property now to log all the records, it has a property to log a limited number of records. By default, it will log only 10 records for each partition. So let's look at those properties, the option that is there. The best part of peak stage that I like is, if I am just doing a testing, I want to create a sequential file, or I want to create anything, any database, any file, anything that I want to create, I need to provide at least the file name to that system. I have to at least provide the file name. Then only it will be creating the file name. Or if it is database that I'm using, I have to at least provide the credentials, connectivity information for the database. For a peak, I do not have to do anything. If you can see, I just dumped the peak stage when I was creating my data stage job. I would just dump the peak stage to the target and just compile and execute it. It worked fine. Without giving any information to the peak stage, it will work perfectly fine. Even though there are options that I can use to modify the content or modify the way the peak stage works or can be executed, but yes, without giving any information as well, I can fix it. I can execute it. So that is the beauty. That is the best part of peak stage that I like. Now let's go back and look into the option that is available on the peak stage. Based on these options, the values will change. I mean, the way the peak stage will behave, that will keep on changing. So if I go to this option set, and I can see that in the stage property there are sections like it says rows, where it says all records and number of records. Two options. Number of records, we have passed it with a counter, and if you look closely to it, it says that number of records per partition. So that means that many records will be loaded in each and every partition. That is the number of records that will be loaded to each and every partition, in each and every partition. So if I say 100, then that means, and my progenitor is generating say 1000 records, then only 100 records will be loaded to each and every partition, not more than 100 records. And if I have say two partitions, so then that means including the two partitions, right, 100 records in each partition, I'll be able to just see 200 records, not complete 1000 records. So that is where the number of records per partition is restricting me, right? I have modified that with the counter, meaning the number of records that the row generator is generating, this peak should log all of them. Whether it be one partition or n number of partition, it should log all of them. Now it is being executed in partition format, and the partitioning is enabled. So that means definitely I'm ensuring that whatever records we are generating the peak stage in the row generator stage, all of them is getting logged in the peak stage. So what is the option here? All records after skip is equal to false. So when it is false, then we have a choice like how many records we want to log in the different partitions. But if we say true, right, so then the partitioning piece is gone. It's going to log all of them. There is no setup that it will say, okay, I can log only 10 records or 100 records. This stage is going to log all the records into my target, onto the peak stage. So it's going to log all the records. But the question comes up is, will the partitioning be enabled here? If I select this choice, will the partitioning be enabled here? Yes, because partitioning is being taken care of by the second section where it says partitioning. So it says that all partition equal to true, meaning whatever partitioning is being provided by the apt configuration file in all the different partitions, we have to log all the records. Now there is no counter available here. It is going to log me all the records. We can test it out with the different examples of execution process, right? If I want, I can say okay, and I can execute it, and I will be able to see that whatever number of records is being generated by the row generated stage, all of them are being logged, and I can check those log values from the director log. So however, if I want that, okay, the peak stage should not be using all the partitions, so then I can click it on false, and I can say give the partition number here. The partition number is precisely from 0 to the maximum number of partition that we are using. We are using 2 partitions here, so let me say partition number 0. If I want to, if I'm suppose using 10 partitions instead of 2 partitions, if I'm using 10 partitions and I want this stage to execute or load the data into 2 or 3 partitions, say partition number 0, partition number 2, partition number 3. So I can click on partition section again, and I can click the partition number on the right hand side, and I can provide the numbers like 3. So then the partition number that I'm giving will be used to log the partition, to do this peak stage logging. Only the data on those partition will be logged. Remember, this doesn't mean that the 2 options that we have selected, okay, will come on what we were speaking in a while. So this is about partition number, but as of now, because this job is executing in 2-node configuration only, let me remove the second option. Let me have only partition number equal to 0 for execution. What if, even if I'm going to execute this job in this way, I will be able to see only, there will be one thing that I will observe. What is that? That if I'm just going to execute this job, if I execute it with say 100 records being created by the row generated stage, that, and this job is executing in 2-node configuration, meaning partition 0 and partition 1. So ideally, out of 100 records, 50 records should go to partition 0 and 50 records should go to partition 1 using round robin algorithm. 50 records to partition 0, 50 records to partition 1. Perfect. But this peak stage is going to log me only 50 records. It's not going to log me the remaining 50 records. Why? Because I have provided that, okay, you log only the data which is available in partition 0. While the row generator stage is going to create 100 records and divide it into 2 partition 0 and partition 1, 50 records each, this peak stage is, and the peak stage is collecting all the records in each partition. Now we are restricting on the partition. We are saying, okay, you don't log all the records on certain partition, only log the records on certain partition. So I'm saying only log the records on 0th partition, don't log it in first partition. So whatever records are there in the first partition, the 50 records will be lost, will not be logged, because we are not asking the peak stage to track the records in the 0th partition. Let's see. Let's do that by executing it once. So for that, let me compile the job now. There has to be certain change in this job and then execute it. So let me create 100 records, execute on run. Now you see 100 records have been created, but if we see the peak underscore dummy and dummy data underscore 0 here, this option, this option is only for 0th partition. The first partition entry is not there. In the previous situations, we used to see there are 2 entries, peak dummy 0, peak dummy 1. We can see the sample here as well. Peak dummy 0, peak dummy 1, 2 entries. But in this situation, we are not able to see 2 entries. We are just able to see only 1 entry in the log, and this 1 entry is going to give me only 50 records. If we count them all, it is going to give me only 50 records. Well, I understand getting a glimpse through this or counting them is a little tricky. So how about we execute it with say 10 records? If we execute it with 10 records, 5 will go to partition 0, 5 will go to partition 1, and either we are getting 5 records on the partition 0 or 10 records on partition 0. We can clearly verify that. We can clearly see that there are only 5 records. There is no 10 records that is being logged. It's not logging the 10 records, it's just logging the 5 records. That is the beauty here. We can restrict it from logging to all the partitions. We can restrict the data from logging to all the partitions by selecting this input. Now the second feature that we have in peak stage is that if I want to log all the columns or only the selected columns. As of now, if we see this example here also, account number, account name, account amount, and account type, all the 4 columns it is logging. because we are saying log all the columns. Now in certain situations when I'm using a peak stage in a real-time project, right, where I will be getting data from the source, the number of columns will be 40, 50, 60 or n number of columns will be there. In those situations, and I want to debug on certain columns, I want to see what is the data coming in certain specific columns. Now when I want to look into the data coming into certain specific columns, right, and these 50-60 columns are being logged, 50-60 columns, something similar to this, we can see certain some example. If I take this example and come here, the last one, so they are being logged with the column name data, column name data, column name corresponding data, column name corresponding data. So that way the entire content is being logged. So that is perfectly fine. But in case of 50-60 columns, it will, this entire situation will keep on rolling over, and we'll get say 7 to 8 or 10 lines of information only for one record. Now it's very difficult to find out the content of my particular column that I'm looking for. So in that case, what we will do is, instead of getting records for all the columns, we can restrict it to give records for certain columns only, where I want to see what is the data in that section. And as I told you, peak stage is used for testing purposes. These tips and tricks are very useful. Imagine you are trying to find out why certain records, certain lookup did not happen properly. So in lookup, what will happen is you will get data from your source, you will get data from your target, you are trying to club them, you are trying to look up on this. Now you want to see why certain records are not coming up, why, what happened in the background. For that, you have to go back and look into the data that is coming from both the inputs for that particular entry. And you know that this issue is because of or the issue is in only certain columns, not all the columns, and the two sections are having say huge amount of columns, 20-30 columns altogether. So then in this situation you need to compare. There is a comparison that will come up, and even if you bring the entry for that particular specific record, each and every record will come in say 10 lines, and it's not necessary that the column structure remains the same, that the first column for both the link is same, second column for both the link is same, third column for both the link is same. So in that case, comparing will be a little tricky. However, if we use peak and we provide the specific column names, saying okay, all columns should not be true, false, input columns to peak, account number and amount. And if I click OK now, execute the same job, that's fine, perfectly okay. Now we see we are getting only two column information, account number and amount. It's not sharing me any other information apart from this. So account number and amount. So only two columns are there. The remaining columns are not available. Okay. So that is the beauty of the peak stage altogether. We will be seeing more in time to come how we can use peak stage at even practically for the testing purpose as well. So we'll be seeing more about that. Now there are certain more stages in this situations, like in the development slash debug stage. We are looking into this option of development slash debug stage. So like we have column generator, we have sample, right, range map, and all that options are there, right? So let's, though all of them are not important from the development and debug stage, only these two are important. But let's have an idea like what are the other options, or what are the other stages that is also available. Let's start with column generator stage. Okay, now as the row generator stage, column generator generates dummy columns, so the values for the dummy columns. How we can test it out? Let me save that as another job. I do not want to modify the same job. Column generator _1 and save it. Okay, In the peak stage, let me make certain changes rather than asking it that it should accept only certain columns. Let me mention it should accept all the columns and click on OK. Now, well, while the row generator generates the entire record, right, it completely generates the entire record. The column generator generates only certain columns, not all the records of a particular column. Only certain columns it will generate. So this means that column generator cannot be your first stage. Like row generator, this stage cannot be the first stage. That is the constraint. So I cannot put it at the first position. I have to put it at the middle or after a certain stage, and then I can join this something like this. This is perfectly okay. Now, while row generator is generating certain records, if I go back to the row generator and see the number of columns coming here, so these are the 4 columns. How about, and we see that I was trying to generate a column called address, which I did not generate. So how about I generate that through the column generator section? So it is asking me column to generate address. Column method is explicit, meaning it will automatically generate the values. There are certain like schema file or explicit. A schema file is the schema file. If you provide a schema file .xsd file in this system, then it will be using that schema file. Otherwise, it is explicit method. Now we are using explicit method precisely. So that means in the output column method, I have to. We see that the address section has already been created. This address column is coming up in the output section. Yeah, you might not be very comfortable with these options that is available, that is coming up. Precisely because we have just started going through the different parts of the training sessions right now. So we were in the input section, sorry, we were in the stage section, yeah, where we have column method and column to generate address. We have provided these 2 options. Now then we can go to the input section and we see the partitioning type. The partitioning algorithms are auto, DB2, entire. So all the partitioning algorithms are available here. While these were not available in the row generator stage because that was being executed in the round robin fashion, but that is available in the other stages. Like we see in the column generator, we can see those partitioning methods. I can choose any of the partitioning method and I can test it out, the partitioning concept that we discussed in the training before. At present, I am mentioning it as auto partitioning method itself. So automatically among the 4 columns, it will generate, it will do the partitioning. Now, precisely what is going to happen in this case is because the round robin partitioning algorithm is getting implemented in the first stage, row generator stage, it is going to implement the same partitioning method. If you remember, the same partitioning method says that I am not going to do anything. The partitioning remains the same as per the previous partitioning. So it is going to follow the round robin partitioning method. It is not going to do any changes to that piece. That is what the partitioning will get implemented if we select auto here. In case I select any other partitioning method, that will be seeing more detail in the informative stages like join and lookup and all. Like if I select a hash partitioning method, I have to, these options which was disabled will get enabled, and I can select the key column on which the hash partitioning will get implemented, which is precisely account name, or I should say account number, not account name. So I can remove this and I can click on account number, and that should be the key column. So in order to for this to work as a key column in a hashing partitioning algorithm method, I have to go to the column section and I have to click account number mandatory over here. This piece has to be done. This key column check-in has to be there, otherwise this hash partitioning algorithm will not get implemented. Even if I'm asking Datastage to auto partitioning using a hash partitioning algorithm, meaning I am using a Datastage join operation, a join stage in a Datastage, and I want it to automatically detect or partition based on the hashing algorithm. So I am saying, okay, you do a hash partitioning, but the partitioning should happen on the account number. So then I have to provide this key column. So this key column is always mandatory. Always remember, whenever you design a Datastage job, go to this input and output column section and select your key column in each and every stage. That is mandatory. If these key columns are perfectly correct and perfectly identified, whether the partitioning method is auto or any other partitioning method, Datastage is going to take that piece without any issues. It's going to work without any issues in that situation. So that is about the key column here. Then we go to the output section and we see there are certain columns here. Drag and drop to the target. All these columns comes up here on the target. Right? We can see, and the point that I'm trying to show you is In the input, we created a key column called account number. We mapped this as a key column in the account in the input, and I dragged and dropped to the output. The key column property comes here. So you just have to make or ensure that all the sources, the column names are correct, the data types are correct, everything in the sources are correct. Then you design your job with this drag and drop approach, and there will be no changes, no issues coming up in your job. Let's test it out now. So I have created a new set. We are creating using the column generator. We have created one more column into it. Let's see if this works. So I'm just going to execute it now. 50 records. So it has created 50 records. Let me look at the data. We see it has generated address or dummy values for address automatically. When we will be using column generator, when in some time for our testing purpose, right, in the real-time projects, because of data safety and security, business will not share me the entire data. Business is not going to share me the entire set of all the records. They may share me certain columns or the data from certain columns, like maybe some data that they will share. Now, like, and they might not share me the account number or account name or certain other details, but they will share me some non-sensitive records, some non-sensitive column information. So what I can do is I can use a file stage to read those records from the file. The next stage I can put a column generator to kind of pass those records to the column generator and create my dummy columns, and then I can test my entire job. So I can I can use this entire process to create dummy data for the columns that for which the data is not provided, using the records for which the data is already provided, and I can create my dummy records. That is where this entire process is, the column generator is used. Let me create another job for this to see how head stage works. So head stage is very simple. It's similar to what we have a head command in Unix. What it does is it gives the top n number of records, but the only difference is these top n number of records that it will pass is from all the partitions. So if I say top 5 records, so then it will give me 5 records from all the partition, meaning partition 0 will show me 5 records, partition 1 will show me 5 records, so at the end I will end up getting 10 records. That is what head does. It will give me top n number of records. Let's see. So without making any changes to the column generator tab, those parts are fixed. I'm just going to check for the head section. I am saying you give me the number of records per partition as 2, only 2 records. So what will happen, it will give me, instead the job is executing in 2 node configuration. I want 2 records, but this stage is going to give me 4 records. I'm going to get 4 records from this stage. Why? Because it's going to give me 2 records per partition. If you see, the number of records per partition is 2, and I am selecting all the partitions equal to true. I have to go to the output section, input section, again the same thing. We have all the 5 columns. I have to go to the output section, drag and drop my columns, click OK, and these records will come to the peak stage. Here also I'm just ensuring that we are using all the partition. No, we are not using all the partition. Partition number is 0. Let me remove this. Let me go to all partitions equal to true and say that the peak stage will be logging information for all the different partitions. This is just to ensure that we get it clarified that yes, we are creating say 50-50 records from the row generator and the column generator. Only top 2 records I am selecting from the head, but how many records I am seeing in the peak stage? So I am generating 50 records from the row generator stage. So from row generator and column generator I should get 50 records, but the head will restrict, it will give me only 2 records. 2 records per partition. So at the end in the peak stage I will be able to see 4 records. We see there are 2 records in peak underscore dummy and data underscore 0, and there are 2 records in peak underscore dummy data underscore 1. There are 2 records only in each of the 2. We wanted to see the 2 records, but we are seeing 4 records now. That is the trick. So if at all we want to get the top 10 records in head, we have to divide it, say 5 records. Okay, so that is the reason, because it is getting executed in partition format, we don't use head here. The best option of using head would be to use it, if required, to use it in sequential file stage. That will be seeing how we can use any Unix command in sequential file stage. So we'll be seeing that part, or to use it as a Unix command if my if it is installed in Unix server. So that is about the head. Tail works in the same way. It gives me the bottom n number of records. Okay, and again the same number of partitions. So the tail stage works in the same way. Let me bring up tail and see how that works. The same information I have to provide here. We have to go to output and say auto match, because the columns of the source and the target are matching. Column names automatically, based on the name, it will match. So if I click auto match, so I have done that, and I'm just going to compile. What we will see is it's going to give me the bottom 2 records. We can compare these 2 records. If we have, instead of using it from the row generator stage, if you're using it from the source, then we can compare that. Okay, top certain records are going to tail, and bottom certain records, top certain records are coming through head, and bottom certain records are going through tail. So we can do that comparison, though that is also very clear about from here. Looking at this number 63146919, the ideally, if these would have been the first initial 2 records, then the number would have started from 1111. But because the numbers are 6319, so that means it looks like they are at the bottom stages and not the start stages, because the account numbers are generated like based on 121. 1111 added with 121 in every new record. So it looks like these are the last records and not the initial records. Okay, the address is YYY and the address is CCC, which are getting generated randomly. And again, if I go to the previous section, if I go to the next section, we see the address is www, account number is 11116798. Again, that is increasing. 7040 again increasing. So this clearly shows that the numbers are getting generated which are towards the end and not towards the start. That is what the tail stage, that is how the tail stage works. Sample stage is used when we want to divide the data into samples. Not used in Datastage projects, but the similar kind of approaches are used in analytical projects, where the data is actually divided into a sample of say 30, 50, 30, 50 and 50, 30, 50 and 20 percentage. So sample stage is used to divide the data into different percentages. It can take 100 records and divide into 20, 30 and 50 records based on the percentage values. Not used in Datastage projects, so we are skipping it as of now. If required, required, we can provide, we can look back into this sample stage in the time to come.